all the controls. I'm making it big.
It works.
It should be recording, but this is what it looked like last period.
Did
I don't
it say
know.
going live? Wait, you move your mouse and it says it's been going for 1 minute and 40 seconds.
So last period, when I started that, it showed that it had been going 18 minutes.
Yeah, something's wrong.
But I have accidentally done that before, that when I was rushing, I slid the thing over there ready to go, and without thinking about it, I just clicked go live and it started. So I don't have a clue what became of that video, but I'm going to go to YouTube and see what happened to the video from last period. I don't even know. Your videos, yes, my videos. So we're recording while I'm trying to solve the mystery from the last time.
Wait.
Videos live.
I know. Wait, is this the stuff where it gets to like?
Okay, live now, upcoming.
No, that's an exponential. That's a quadratic.
Okay, that one needs to be
You
deleted.
don't know all those? Yeah.
Stuart, what if you go?
Hang on just a
I
second.
hate that.
Okay, that's one that crashed and burned the other day, but I got it. Trig notes 2.4. See, it never, ever took the trig notes last period. It still says it's upcoming. So I don't know what's going on. But we are going live now. So let's just take the notes. Okay? And y'all are so eager. Y'all are already answering what goes here, huh? All right. Let's talk first about, do you owe me stuff right now? I am starting to get submissions from this major grade, which y'all have had several weeks to work on. So I've gotten a few of them emailed to me. And so as you get me those 2 parts submitted, which you have today, tomorrow, and Friday, then turn the instruction page in with your name on it, because that's what I do my grading on in a record if there's information missing or whatever. Okay. CMHW 5.2. We finished 5.2 yesterday. I'm just nice giving you an extra day to get it done. Turn it in tomorrow. That one's totally on clean paper.
Yeah, I think
Okay.
it's in
All right. Some people did. Okay. And then extra credit, Delta Math. If you have a daily grade that needs to be dropped, make sure it's done by 8 a.m. on Friday. So this one, you got some practice problems. And there's a little hint for number 9. That hint for number 9 would go with anything close to number 9 down here, maybe. It says the 2 miles per hour value should be plugged in for the X. So when you read that problem, that will help you figure that out. Okay, so now y'all were already saying a blank function is a function in the standard form of blah. So what type of functions are we talking about? And how did you know that? It says discovering quadratics. Now, what is it that makes a function a quadratic instead of a linear? How do you know how do you recognize a quadratic function and know that it's not linear?
X squared.
X is squared. Okay. You may also have a regular X, but you also have an X squared, and there's no higher exponent anywhere. Okay. So the highest exponent controls the function. So if it was an X squared, but there's also an X cubed, you got a cubic function. If you have an X squared and there's also an X to the 4th, you've got a quartic function. We're not going into all of those. All right. So quadratic, and I heard some of you throwing it around here. So what is the standard form of a quadratic?
A squared.
Okay. A x squared plus bx plus c. Now, those 3 terms each have names. Okay. What do you think we call this c that's at the end and doesn't have a variable with it? It's a constant. Very convenient that it happens to have a c, right? Okay, then the alphabet is not going to play in our favor for the rest of these. All right? What do you think you call the first term that's squared? Okay, well, I give you a hint. It's when you have x squared, you know your problem is. So that was the term that told me that this was quadratic. If I did not have an x squared term, I wouldn't have a quadratic function, okay? So y'all, let's say I removed the x squared term.
Linear.
It's linear because it's like mx plus b, isn't it? So guess what the name of this function is? I mean, this term is linear. This is your linear term. All right. Now, if you graph a quadratic function, it doesn't form a line, does it? What shape does it call?
Parabola.
It's a parabola. The common name for the graphical representation is a parabola. So we are going to be dealing with parabolas today. You all got calculators on your desk? Okay. So we're going to look at some attributes of parabolas. We're going to learn some terms here. So we're going to start off. It says use a graphing calculator to sketch the following graphs. And I'm okay with just a loose sketch, but there's a couple of things we want to make pretty good. So I'm going to go into my y equals, and I'm going to type in that is negative 2x squared plus a 3x plus, oh, I didn't get my x. I just said it, plus 4. All right, if I want to sketch the graph, what do I do in my calculator to get an idea of the picture? How do I get the picture? Press graph, okay? All right. Huh. Okay. So the vertex is about where?
It's 1, 5.
It's about 5 and about over 1. All right.
I used the table. I think I did mine wrong.
Okay.
It still goes
All right. You could go to the, okay, go double check your numbers. Make sure.
negative 2x plus 3. Oh, that's negative 3x plus 3.
Yeah, I also almost forgot to put in my x. Okay. If you're not sure, we could go to the table. The table may not give me the exact vertex because the vertex might not be at a really pretty point. It's kind of close to 1, 5. But you know how I know that 1, 5 is not actually the vertex? If I look at the numbers above and below, they're not matching. So that's not the exact tippy top, but it gives me an idea. Or if it's a sketch, I'm okay with you just kind of looking. I'm hitting the x-axis, not exactly at -1, but kind of close to -1, aren't I? And where else am I hitting the x-axis?
2, but not really 2.
A little bit past 2, but not even quite to 2.5, right? I think that's enough for me to draw a halfway decent sketch. Y'all, quadratics are not as easy to draw as lines. You don't have a quadrat hanging around your neck. Where's your straight edge, girlfriend?
My backpack.
You have to go get it. Okay? All right? So you need to get in that habit because I am more likely to notice while we are doing graphs.
Okay, isn't there a way you can find the vertex, right?
You can, and we're actually going to hit those skills in this section. So there's several calculator skills that will specifically find those.
I know, but I remember not doing it on the calculator.
Yes, then we are also going to do a non-calculator way to find the vertex as well in this unit. Okay.
So we were on this lesson because we were in algebra honors too for like a good 2 weeks.
Yeah.
Or, no, probably 3 weeks.
Yeah, you spend a lot of time in Algebra 2 on parabolas.
Yeah.
Okay, there is a term I need you to know. If the vertex is at the tippy top, there's a name for that vertex. If the vertex is at the top versus at the bottom, anybody know what that's called?
It's
That
like
point.
open.
Okay, it's the maximum because this y value is the highest value we've got, right? So this will be called the maximum because it's the vertex is the highest point, correct? Why do you think this particular function had a maximum?
Because the quadratic was negative.
Because the quadratic is negative. Exactly. Okay. Now, so let's try the next one. What do you think it's going to look like when the quadratic is not negative? It's going to be opening upward. So what word do you think we're going to use there? Oops. I totally put absolute value instead of a fraction. I'm not even sure what happened there. I got it. Be warned, I am trying to remember the ID thing. So try to remember to get it on before first period. Okay, punching in this guy.
Nobody.
All right.
We don't do that there.
Yeah. Oh, I've got one of the calculators that gives me a fraction right there. And not all of them have that little fraction box right there. Some of these calculators are a little bit older. All right, x squared minus x minus 1. Looking at the graph, we're not surprised that it opens upward, right? Okay, about where does that vertex look like it is?
1/2.
Over maybe 1. Okay, we could go to the table. All right, since I put in this leading coefficient as a fraction, it's giving me fractions. The vertex looked like it was around over 1. And do you think over 1 is the actual vertex? So do you see how my fractions are matching perfectly
Oh, yeah.
on above and below? That means that you have exactly found the vertex. You won't always see the vertex on the table though, because sometimes the vertex is not at a pretty crossing grid point. All right. So if I go to,
One second, mine's in like the 2000s.
okay, wait, where am I getting my exact match? It's the negative 3/2, right? Over 1, down 3/2. All right. Or I could also just look at the graph and go, okay, looks like it's hitting the x-axis at about -1. Looks like it's hitting the x-axis at about 1, 2, 3, almost 3. Almost. What is wrong with what I just did?
You put the second.
I didn't put that in the right place. Wait, no.
Uh,
That's not 3, that's 4. Okay. Duh. All right. And final. Oh, I counted 3 from my vertex instead of from my origin. That really was a big duh there, wasn't it? Okay. After this, I'm going to curve. Hey, you guys, listen to me right now because people were losing points on what I was grading yesterday. First of all, some of the students, when you're drawing the points, they're just like putting a little point with just tapping their pencil down. And then when they draw their line, I can't see it anymore. And I'm not seeing it. If I'm having to squint to see if you actually drew points when I need points, I'm not going to give you credit. I'm also not happy if you don't take something all the way off the edge of the grid. So yesterday, when y'all were actually graphing actual ordered pairs from tables, or I was grading something you turned in yesterday, and you were graphing the actual points, if I couldn't see the points, you lost something. And there was only one person that didn't listen to me, that didn't go off the edge of the grid with an arrow on the end. They lost points for that too. Okay? So I don't think, it may not have been in this class. I just remember grading one paper like that. Okay? So we got that puppy graphed. So what do you think this means?
What happens when a
What am I talking about when I say A?
quadratic?
A is the leading coefficient in the quadratic, isn't it? It is ax squared. What happened to the graph when a was,
Less than 0.
what kind of numbers are less than 0? So if you have, this is saying what happens when you have a leading negative. Now that is assuming that you have your quadratic term first, then your linear term, then your constants. What does a leading negative do?
The parabola opens down.
Good. It opens downward. All right. So if it opens downward, you have a maximum point at your vertex. If it opens upwards, what would you call the vertex? The minimum. It's important to know those two terms, mainly because there will be some situations where we use the calculator to find the vertex. And to get the calculator to find a vertex, it asks you, it doesn't say find the vertex, it says looking for the minimum point or the maximum point. So you got to know which one you're looking for. Okay? So label the vertex in each parabola as maximum or minimum. Then let's talk about the axis of symmetry. Have you heard that previously?
I think so.
Okay. All right. So what do you know about it?
I think in Algebra 2, I just remember doing the parabolas and we had to put it like this in between it, and then there was something about it
Okay. So what does the word symmetry mean?
that both the sides are the same.
Both sides are the same. When you were a little kid, you would take a piece of paper, fold it in half, and then cut out half of a heart and open it up, and boom, you would have two sides of a heart, right? That fold line was the axis of symmetry or the line of symmetry. Parabolas are symmetric.
Yeah. Don't you have a solve for that at one point?
Well, if I'm just asking you to draw the line, you just need to be able to see the vertex. But if you were going to give me the equation of the line, it will be a vertical line, and it would cross the x-axis, and you would tell me the equation of the vertical line by saying the axis of symmetry is x equals, in this case, 1. I don't believe you're going to be having to name the equation of that vertical line in this context. I just need you to know what an axis of symmetry is. We usually draw a dotted line. That little red didn't show up much. I'm going to use my yellow highlighter here. It has to go through your vertex. Remember, you were just sketching. In this case, if it says sketch, it is not a super perfect graph. If I want a really good graph, I will make you plug in values and graph points specifically, and then connect the dots. All right? So line of symmetry, axis of symmetry is going to be a dotted vertical line that passes through the vertex, because the vertex is the point where it folds. Like we were seeing the calculator, if the vertex is at a nice point, you will see on your table that there's a certain y value, and then above and below, they all match. Okay? If you can't find that in your calculator, it's because it's not at a pretty point. All right, let's go to the next page. All right, so now we're going to get into the details for graphing quadratic functions, and you are going to see and recognize probably some of the formulas that you were saying, hey, isn't there a way to find this a second ago, Hattie? That's about to come up. All right. If I ask you to graph a parabola that is given to you in the form of f of x, or in other words, that's how you find your y values, is equal to ax squared plus bx plus c, we're going to use these steps. First of all, I will want you to decide if the parabola opens up or opens down. How are you going to know that?
Go to graph.
Yeah. So if A equals 0, or is greater than 0, so which is positive,
Minimum.
or if A is negative, it's going to open downward. So on the previous page, I used upward, downward, okay? Here I just said up or down. I'm just okay with that. You can say opens up, opens down. That's good enough for me, all right? You'll see this, what are we on, 5.3? 5.3 for your CMHW. This one has a worksheet because you need grids, okay? And so on here, there's several where they're going to ask you questions that come from these steps. So I've given you places. You copy the function, you tell me if it opens up or down. You find the vertex, and they're looking for x-intercepts, y-intercepts, and then you sketch a graph. So that's what we're working on right now, is learning all those steps. So, okay. We can tell if it opens upward or downward before you even put it in the calculator. So, to find the vertex, when you are in standard form and you've got this A and this B value and this C value, all right? And those are the coefficient of x squared, the coefficient of x, and just the constant at the end. We can use those. Some of them are used to find the x value of the vertex. There's a formula here that uses some of those letters. Do you know what it is? This is not the full, whole, gigantic quadratic formula, which helps you find where your x-intercepts are. This just tells you the x value of the vertex. I'll tell y'all. It is a fraction, just one, but it's not a giant fraction. The top of it, I want you to listen carefully. It looks like I've written negative b. I need you to see that as the opposite of b, because you're changing the sign of whatever b is. It's not always going to be negative. If b starts off negative, you're going to be writing it as a positive letter.
So would it be plus or minus b over?
Okay, so you're going for the whole quadratic formula, and right now we're just going for a piece of it. So we're removing the plus, minus, and the giant square root. So the only thing that would be left is the opposite of b. And do you remember what's on the bottom of that formula? Over 2a.
Okay.
Now let me say that again. Does that sound familiar? Opposite of b over 2a.
What's the full quadratic?
Okay, this would be a
Square root
much
of
longer.
Plus or minus b times whatever.
Okay, it's actually plus or minus before you get into the square root, and inside the square root, it's b squared minus 4ac.
Yeah, I remember,
Okay.
I remember that.
And that's coming up at the bottom of this page. And we'll talk about it more when we get there. Okay, now this is just a piece of it. It completely leaves off the plus, minus, and the square root. This is very easy to do. This will find you the x value of the vertex. So if I give you, so a minute ago when you're saying, isn't there a way to do that? So if I flip back to this page, Addie, if I'd looked at this and I needed to find the x value of the vertex, I would have said the opposite of 3, negative 3, over 2 times negative 2 be negative 4. So it'd be a negative 3 over a negative 4, which would actually be positive 3/4. Does it look like our vertex may be around 3/4 maybe? Maybe. Okay. Does that make sense? Now, once you find the x value of the vertex, you can find the y value of the vertex. Plug what into what?
I feel like it's all.
No, we don't even use C for the vertex. So C is not used in finding the vertex at all. But if you need to find the y value, couldn't you plug x in?
Yeah.
So now that you just found your x 2 seconds beforehand, you plug the x into the equation.
What's so old, like forgetting all that?
Yeah. I don't think it's old. I think it's just, you just haven't used it. I mean, if you think about all the Algebra 2 you stuffed in your head last year, for those of you who had Algebra 2, you haven't used much of it since then. You stuffed in a bunch of other things. So,
Barely got through that.
all right. Now, the next thing that it's going to ask you is the x-intercepts, which may not even exist. It is possible that you have a parabola that's floating up in the air and never hits the x-axis. Well, there would not be any x-intercepts, but you're going to try to find the x-intercepts, and you determine the x-intercepts by substituting x for the f of x or the y and solving for x. I think those are the words straight out of the book. Okay? I think that's a lot of words. And if I weren't going with the definition straight out of the book, I would have just said set the equation equal to 0. Does that sound more like something you would have heard? That's what they're really saying. Replace the y or the f of x, whichever one they have at the front, with a 0 and solve. Now that's where things get sticky. Solving for x is going to take one of two skills here. You are either going to have to factor your quadratic into two separate factors, or you're going to have to use the quadratic formula. The quadratic formula will work every single time. It's more work than factoring. You shouldn't have gotten into this class without being able to factor. So let's talk about that for a minute, because some of you are going to be frustrated because you cheated on your college bridge. All right. So it is virtually impossible to pass the TSI test without knowing how to factor. So some of you got in here because you passed your TSI, or you may have had a really high SAT score. I know you know how to factor. Okay. Then, so TSI wasn't working for y'all. You went to college bridge. Okay. There was a few kids that passed the college, right? Well, I'm mixing up my TSI and the college bridge. TSI, you might have passed it on the first round, or you may have had to do all the extra problems and you recovered it there. But if you ended up going the college bridge route, it was because you weren't passing the TSI. You were not college ready. And the purpose of college bridge was to practice and practice and practice your skills until you knew them. All right. Some people didn't actually do their own college bridge. There are some people that photomathed everything. There are some people that had somebody else do their college bridge for them somewhere else. Those people are not going to do well in this unit because they cheated their way into this class. They didn't actually prove they were college ready. They cheated. That being said, most of the skills that they cheated on, they've been able to survive in this class so far without those skills. But this is our most algebra-based unit. And if you cheated on your college bridge and you had somebody else do it for you, or a computer program do it for you, you're going to be kind of frustrated here. I don't know what to tell you. I will show you examples, but I'm teaching this class assuming you actually were college ready. Okay, so I'll give you examples. The factoring are not super difficult factoring problems, but if you haven't done it, you haven't done it. Okay, all right. So this setting the equation equal to 0 and solving is either by factoring or using the quad formula, which we will have at the bottom of this page. We will see examples of both of them here in a minute. Okay. Your x-intercepts are the points where your parabola is hitting the x-axis. That's what x-intercepts look like. So there's a little picture showing you what x-intercepts look like. Okay? So you're looking for those 2 points. The next thing they're looking for is your y-intercept. Well, your y-intercept will be where your parabola hits the y-axis. You could have two x-intercepts, but you cannot have more than one y-intercept because it would not be a function. All right? To determine the y-intercept, you are going to substitute 0 for the x. You are going to plug in 0 for the x. Okay? And once you plug in 0 for x, all the terms that have x's are going to go away, right? So you'll just be left with y equals a number. And that will be where the y-intercept is. Okay? Then you go to the graph and you plot. By this point, you have a vertex. You go put that on the graph. You have x-intercepts. You put those on the graph. You have a y-intercept. You put that on the graph. At that point, you have enough points to get an idea what the graph looks like, and you just connect the points to give the graph. That is the methods that this book wants you to do for graphing. And on your homework, there's some graphing where you have to go through these steps. So we are going to go through those steps for a couple of examples. All right. Now, take a look. Do you see what I have typed here? Where it has the function, tells you where it opens, has vertex. You find the x, you find the y. Then you get the x-intercepts and the y-intercepts, and there's a graph. That's the same stuff that I put in your workspace on the worksheet for the few problems where you have to do this. So here is my function. Just looking at this, not using my calculator, but just looking at this, is it going to open up or down? How do you know? The leading term is positive. It opens up. Okay? Now, what did I tell you to do to find your vertex? Okay? And don't say negative b. What do I want you to? I want you to hear in your head opposite of b over 2a. It's really important to think of it as opposite because you're going to have to change that sign. So what? Your a value is your leading coefficient. This is your b. This is your c. Y'all, what is the a here if I don't see a number in front? Understood 1. Okay. What is the opposite of my b value? Negative 2 goes on top. And what would 2 times my a be? 2 times 1 is? All right. Can I divide that nicely?
Yes.
Okay, negative 1. What have I just found? Okay, not the whole vertex, but the x value of the vertex, correct? So let's start drawing ourselves an ordered pair for our vertex, and opposite of b over 2a only finds me the x value of the vertex, negative 1. All right, so we're halfway there, right? So
Wait,
now,
why did we put a negative for the a? Why would we change our a?
okay, I didn't change my a.
No, you put negative 1, right?
I said because I used the opposite of my b value. B was 2, so I plugged in a negative 2.
Oh, okay, not gonna lie, that equal sign looked like a negative. I was so,
Wait, what?
at the very beginning, you put 1x, I thought you put negative 1x.
Oh, that's a 1. Gotcha. No, I'm just, yeah.
That's
Okay,
it.
now we're good? Okay, because I could not figure out what you were talking about. Okay, now we're good? We're great. We're great. Okay, now, how do I find the y? According to this, what do you do?
In x.
Okay, so y'all, I have a function right here. Fred woke up this morning and here's this function, and I need you to listen and watch this super carefully because people blow this. And people blew this on the assignment I graded yesterday, and the only thing I can think that they might have done wrong is they didn't draw parentheses when they're plugging in. So let's think of this in terms of playing Fred and George. Fred's rule is something squared, right? What else is part of Fred's rule?
2 times something.
Plus 2 times something.
Minus
If you do not put those parentheses and you plug in a negative number, when the calculator squares it and you don't have the parentheses, it's not going to know that the negative also got squared, and you will get the total wrong number. So be very, very, very careful when you're plugging into the function to use the something parentheses, okay? Now, at this point, maybe you could do the math in your head, or maybe you just want to type that in. What is -1 squared?
Oh, that's one.
Positive 1, okay. What is 2 times -1?
-2.
And we have a -8. So maybe you can combine all those in your head, but if you type it in, make sure you are typing the parentheses, okay?
Wait, I'm so confused. I thought we said we were plugging in 0.
No. All right. You're plugging in the x value into the
So
equation
we're not
because,
down there yet.
yeah, because think about it, okay? Come up here. F of x is a fancy way of saying y equals, right? So y is equal to plugging something in for x. So we found the x. So this is the y that goes with that x. All right? So now, what would this turn out to be?
No? I thought he was on.
-9 because the 1 is positive.
Yeah.
Okay, so that would end up being a -9. You have my permission in this classroom to use a calculator as you calculate that. So now, what is that -9? The y value of the vertex. So I will be graphing that point. I could go ahead and do it right now. -1 and then down 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my vertex. The next thing I need to find are the x-intercepts. What did I say about finding x-intercepts?
Set the equation equal to 0 and so on.
Okay, so the equation, would y'all rather me say equals 0 and have the 0 on the right side or on the left side? Okay, so I'm replacing the y with a 0, and I'm saying x squared plus 2x minus 8. Well, y'all, I am going to factor because this one factors very nicely. So, what I'm factoring, if you factor a trinomial, it will give you 2 binomials. So I'm making my parentheses wide enough for 2 of them. Now, if you are factoring, listen to me carefully. I am looking for a combination that would multiply and give me a -8, but it would,
Equal to
it would subtract and give me a 2. If your second sign is a minus, you're subtracting. Okay? All right? So, first of all, how am I going to break down the x squared?
x plus and x minus.
X and an x. One of them has to be positive, one of them has to be negative. If it is a minus, these are 2 different signs.
The larger number has to be a negative.
Actually, the larger one has to be positive because the larger one will always be whatever this is because I've got to have more positives, okay? So what is something that multiplies to equal 8?
4 and -2.
Okay, a 4 and a 2 would equal an 8. If I subtract them, it would need to be a positive 4 and a -2. Now, if I was just factoring, I would have stopped right there. But it is set equal to 0, so I need to solve for what x's would have made this equal 0. Y'all, for this first parentheses, what could I put with this positive 4 that would have made this parentheses equal to 0? A -4. You are just changing the sign if you take it out of the parentheses. Okay? And I don't think it's going to get much harder than these. You're not going to be factoring trinomials with leading coefficients here. We're not going super algebra 2 here. What would your other x value be? Positive 2. Because you're saying, what would make that parentheses equal 0? Okay? So that is my 2x intercepts. You could write them as ordered pairs. One of your x-intercepts is -4 up 0. The other x-intercept is 2, 0. Or I could just say, let me go on my x-axis and put a point at -4 and a point at +2. All right. Now, y'all, the y-intercept is a whole lot easier. Go back up to where I said how to find the y-intercept.
Plug in 0 for x.
So if I look at this equation right up here told me how to find y, right? Y was equal to something square plus 2 times something minus 8. Agreed? I'm putting zeros in for those.
So y equals -8.
So the only thing that's going to be left is your constant if you put 0 in for all your x's, right? So the y is at -8. That means on the y-axis, I will go down to -8, 1, 2, and put a point there. Okay? That ordered pair has a 0 for the x, because I plugged in 0 for the x, and y was -8. That's all the points I asked you to put. I need them to be large enough so when you draw your curvy parabola, those points don't disappear underneath your curve. And then I don't know that you put them there. Because when I grade something like this, I'm going to look for these 4 points exactly. Now, this is my vertex. So I curve through my vertex, and now I'm just sketching. It gets up, up, off the edge of the grid with the arrow on the end. Those are the steps you go through. If it wants to factor nicely. If it doesn't factor nicely, we will use the quadratic formula. So if it's not a really just plain little x squared, you'll go with the quadratic formula, which is where we're going to start tomorrow.
Did the grade class with us?
We ended up at the same place yesterday. All right, this video seemed to, I still cannot figure. Oh, and